All right, thank you for the opportunity to present today. We are Element 5. We are a mass timber manufacturer located in Ontario. Next slide, please, Nick. We're in the midst of a revolution in the construction industry, one which began in Europe 25 or 30 years ago and is now well on the shores of North America. It's made its way all across Canada and is now well into the United States. It's a revolution that's characterized by buildings that are being prefabricated off-site, and rather than being assembled or constructed on site, they are simply assembled on site. This is the Brock Commons building. It's a student residence at the University of British Columbia, and I think this is reflective of the future of construction. It's an 18-story building. It was constructed on a concrete podium, and off to the left-hand side, you'll see glulam columns. So these glulam columns sit on top of the concrete slab, and on top of the glulam columns, you'll see CLT. These are cross-laminated solid wood panels. You'll see one being flown into place there, which sit on top of the columns, more CLT, up 18 stories. One of the things that's really interesting about this particular building is this is one of the first buildings that had prefabricated envelope panels, which were applied to the outside of it, a mass timber building. I mean, this building was rendered completely weather-tight in 9.5 weeks. And so when the industry saw what was happening with this particular building, it started to take notice. Next slide. The concrete and the steel industries are responsible collectively for about 25% of the world's carbon dioxide emissions. However, when you're building with mass timber, what we're doing is we're leveraging the world's forests to absorb that carbon dioxide and to store the remaining carbon in ever-increasing amounts of wood. And if you manage your forest properly, as we do in Canada, US and elsewhere, and you use wood, therefore, to construct things, and in this case, buildings, you've created a system that's the complete opposite to the concrete and steel industries, which instead spew carbon dioxide into the atmosphere, to one which, in fact, remove carbon dioxide from the atmosphere and store it in the form of these beautiful buildings. Over to you, Nick.
All right, I'll take it over from here. Alrighty, so, to achieve the benefits of mass timber that, Patrick alluded to in the previous slides, there's a couple different categories of areas that we need to focus on, and Element 5 focuses services in all of them. So number one, we want to look at structural design and detailing, and what that means is, either you're bringing on a mass timber engineer, such as Element 5, or the mass timber fabricator is offering design assist services to the engineer of record or to the architect to avoid common mass timber design pitfalls. Second category, we have detailed 3D modeling, where to have a successful mass timber project, you need to create a fully developed LOD 400 ready for fabrication model. Which brings us into the third category of production. And by taking that model, the guys at our factory will mad at me for saying this, but you effectively hit print, and then those CLT panels and glulam elements can be built in our state-of-the-art factories in St. Thomas, Ontario, or Ripon, Quebec. And then the last category there is installation, where we focus on creating efficiencies during the construction stage to reduce time on site, which further reduces greenhouse gas emissions. Now, Tristan stole my thunder a little earlier with this McLeany curve, but we're going to use it too. We're going to go through it line by line here. So to understand the mass timber design process, this graph shows time on the x-axis, which is all of the design coordination phases. And on the y-axis is the amount of effort required depending on the curve. So the first line here is the ability to impact cost. There is significant potential to make changes to a design earlier in the design pipeline, but as Tristan mentioned, the further you get to construction or operations, the much harder it is to make that design change. Line 2 refers to cost of design, and it's basically the exact inverse of line 1. As you get closer to construction, if you want to make a major design change, it's going to cost you a lot of money to actually make there and take a lot of effort. Line 3 refers to the typical design process where a lot of the details are worked out in the CD phase. And line 4 is where the mass timber industry wants to sit, where the majority of coordination is done up front. Much like Tristan mentioned, where the focus of a passive design needs to be put up front. If you're looking to move to a mass timber solution, that needs to be something that is decided and coordinated as early on in the project as possible. Common design choices that are chosen for steel and concrete buildings can potentially eliminate the ability to use mass timber as you move throughout the design process. It'll end up costing a lot more for you to revert back. And by getting everybody involved early, you can get all the trades aligned with the design, a detailed design for manufacturing model can be developed, and time on site can be reduced with proper coordination. So now going into the 3D modeling aspect of our workflow, we're going to use an example of our largest project to date, which is the Toronto Regional Conservation Authority headquarters, which of course, given the name of the organization, just had to be built in mass timber. So this is a rendering of our full LOD 400 model ready for manufacturing. We've modeled every individual 500 of the 567 CLT panels, 1,061 glue-lime elements, and 320 unique connections. Beyond that, every penetration, every screw hole has also been modeled, so that all of that work can be done, prefabricated in the factory and ultimately reduce time on site. What this requires is intense design coordination with MEP and other trades to ensure every penetration in the structure is accounted for upfront. Where typical construction would require a lot of these details to be coordinated on site, instead we're coordinating this early on the computer with all the appropriate trades to ensure everything lines up, there's no clashes in the model, and the building can be erected seamlessly. So here is now moving on to the third category, we're going to look at production, and this is a model or rendering of our factory in St. Thomas. And honestly, this doesn't do it justice for just how big this factory actually is. The factory will be fully operational by April 1st of this year. All of the wood that we will be used to produce our CLT panels and glue-lime elements will be made from Ontario forests, and all the wood will be FSC certified. And when the plant is up and running, it'll be the most automated mass timber manufacturing plant in the world. And we will happily hold that title for about 4 to 6 months until the next one is built. This set of photos might do the factory a little more justice, just to show how big it is. You can now see people next to the massive machines. And what we're showing here is the volume of wood products as well that we can produce. At full capacity, we can produce about 50,000 cubic meters of mass timber in 1 year. And what that means is, we talked about Brock Commons building earlier. When that was built, that was the tallest mass timber building in the world. And our factory has a capacity to produce about 22 Brock Commons in a year, which is, incredibly exciting for the amount of mass timber potential. But interestingly enough, in terms of scale, all that wood can actually be regrown in North American forests in about 135 minutes. So, we're still, well within a sustainable mindset there. And then for all that material, the total potential carbon benefit is about 62,000 metric tons of CO2, which is like taking 13,000 cars off the road in a year. Another image from the factory, just to show the capabilities as well, is on the left there. We have the first item that came off of our state-of-the-art CNC machine, and it's very clear that the CNC work can be very high fidelity. And on the right there, we have our X-Press, which is a monster machine that produces the CLT panels. We can use that to produce some of the largest panels in North America at a total size of 3.5 meters wide by 16 meters long by 315 millimeters deep. Though if you actually need a panel that big, that was because we didn't get involved early enough to coordinate the design. Now, all that being said, one of the problems that we have with the mass timber industry is that we want to avoid being considered a component supplier, because as it was alluded to in the other presentations, every design is different, every project is unique, and so just having a set of components, the way you would have like a set of screws, is not going to be able to use mass timber to its fullest potential to solve the climate crisis. So what we have instead here is images from our innovation center in Ripon, Quebec, which is our other R&D facility, which works with finding unique solutions to a wide array of construction problems to ensure mass timber can be used in a variety of different ways and help use mass timber to help solve the climate crisis. So for example, some of the images here you'll see is our box panel, which is basically like hollow core concrete slabs, except consider it CLT. And the next one I'm going to show is our CLIPS system, which stands for cross-laminated insulated panels. So very similar to the image shown on the second slide of the Brock Commons building. This is our prefabricated envelope system, which is high performance, airtight, and has a CLT layer, the vapor barrier, insulation, and strapping all included. And there is potential for us to also include the cladding and windows and doors, all pre-assembled in the factory so that it arrives on site as one solid element. Originally, this was designed for a mass timber building so that both the structure and the envelope could go up simultaneously, side by side, enclosing the building as quickly as possible. But we've realized and had quite a bit of success with offering clips as a solution to even concrete and steel buildings. Which brings us to our fourth category, which is installation. So if we have done everything right up until this point with all the pre-coordination and planning stages, the mass timber products come to site and can be installed like Lego or K'NEX. As you can see kind of in the top of this image here, all of those glue lamp panels have been pre-CNC'd for all of the connections so that everything slides into place perfectly, and there's very little extra work that needs to be done on site. Connections can even be pre-installed in the factory. If everything's done properly, we've seen a mass timber product be able to be erected at a rate of about 8,000 square foot of building area per day with a mass timber solution. So the last image I'm going to show here is another example of how mass timber can be applied quickly to site. This is an image from the Oakville Fire Hall, one of our projects. And you'll notice there we also have our clip system at the top of that wall. But the point I want to drive home here is, all the pre-coordination work for this panel was done, on the computer, off-site, and then prefabricated in the factory. It then arrived on a truck, was lifted into place by a crane, slotted into those connections that were pre-coordinated, temporarily braced, and then the whole wall was installed. So just like that, the entire wall of that building goes up and then becomes airtight really quickly. There's no pesky concrete forming, no building steel stud walls and filling those walls with insulation. All that tricky coordination work that would have added person hours to site is taken from the construction site, put either in the factory or on our computer work. And that is further reducing time on site and reducing greenhouse gas emissions from construction. That's our presentation. Thank you very much for listening. We're very much looking forward to the discussion with the panel.